What's up, everybody? CT Saturday night, and we're gonna continue on with the planning. So, what are we gonna do next? So when I was running Unity earlier, and so cake domain seemed fine, but when we ran the rocket domain, besides it kind of falling out of the sheet, I noticed that there was different copies, like bot, load cargo, rocket NOLA, unload cargo, and you see that twice. And then you go up here and you see like fly rocket NOLA 4 times. So something's amiss here. So we're gonna go try to figure that out. I opened everything up and just kind of browsed the code for a sec, and I noticed the camel case versus the capital case in C#. So Java uses a lot of the camel case, which is like equals. So I'm wondering if that has something to do with it. So I'm definitely going to start it off there. So I guess we can't override in an interface, but what is the first abstract class? I already forgot. Let's see if I still have my pictures. Here we go. Okay, so here's my pictures. At the expression object and the term object, we gotta have our equals ready to go there. So let's go ahead and find those codes, those classes. So what was the first one? Expression or expression object? Expression object. All right, so here we go. This is what we're gonna do here. We're gonna override equals. That one seems fine. So that's actually not an override. So I might leave that as a virtual. But this one is totes gonna be an override. So you're more of a virtual. Oh, I already have that happening. Okay. Let's just say equals and equals. Okay. Man, why not, right? We are getting to that stage where we're totally converting this into C# code, so I'm gonna go all in. Okay, yeah, that's looking pretty good. So we're gonna go to expressions now. Why not? I'm going a little crazy on this thing. I am changing these to capital letters until I can fix my issue. I'll come back to that. And then expression object. Here we go. What are we not implementing? Does not implement substitute. Okay, we'll figure that one out. So equals, get hash code, equals. I'm gonna open up Java too, the original Java. I just want to make sure I'm kind of doing what the teacher's doing. Because right now we're just getting the hash code of the object, and I don't know if that's what we need to be doing or if we're getting the hash code of the string. Okay. So we should have Eclipse coming up any second now. And I'm going to be watching something right quick. Nice. Alright. We still got 3 more downs to stop them. Or 2 more downs. Oh, you're asking me something. Missed it. Let's go, Eclipse. Oh, shoot. Wait for it. Alright, well, while that's kind of going, I'm going to go ahead and just keep looking through this code. So, okay, when we're looking at the strings, we're definitely comparing. Nice, we stopped them again. If you're curious. Whoa, okay. Planning. Source. Logic. First I'm going to look at your formula. Yep, I'm doing that for sure. Equals, okay. And then your expression. Okay. And then expression object. Oh. Oh well. Okay, so that seems like we're doing that for sure. So let's go back to C, figure out what we're doing. Does not implement expressions that substitute. Okay, well, that's what this is, right? Or you know what, I'll just rename it just in case someone else is using it. Alright, good deal. So that seems fine. Boolean and n-ary. So let's go Boolean. Does nothing. N-ary. Yep, this equals needs to be capital. Capital. Yeah, sorry. So we're looking at the expressions, just making sure that all their capitals and everything. So get hash code to string. Oh, yeah, alright. So substitute there. Yep, give me the error list. We should always make sure we're doing the rename, just in case. Okay, that looks fine. No problem. I'm sure that's just you being crazy. Whoa. Okay. Yeah, so cleaned up the error so far. I'm not going to get too much into it. So let's go back to n-ary Boolean expression. Yeah, definitely need to make sure everything looks good there. So if we're at like the expression object level, yeah, okay, just checking everything out. And then, oh yes, that's what I wanted, the strings. So you're just comparing toString and toString. And toString, we don't know yet what it is. Alright, I feel better about that. Is it virtual though? Formula, right? So first we get a formula, comparable formula. You gotta have a compare to function, right? So if I go to this expression object and I just said, hey, what? I just say, hey, compare these two things. Yeah, okay, good thing. Good deal. Okay, so we have to have this compare to function. Yeah, and it being virtual probably is a good idea. Alright, cool. I don't think I fixed anything with the equals, but let's see. There's always a chance, right? So it's with the rocket domain that we're having issues, so I'm going to hit the rocket domain. Yep. So these two things are supposedly equal, but they're not. Sorry. There's one place I want to see that whether it is like duplicating or not, and that's with this state space search or state space node, state space problem. That's what I want to say. So if I go to planning, plan graph, we're gonna get a state space problem right here, and I just want to see what it says or what it does. So we're gonna attach it to Unity. Once it says ready, we're going to bring it over to Unity, hit play, go to rocket problem. Here we go. Now we're getting the plan graph. So I'm going to hit F10. Oh wait, I don't care about this part. So continue on. This is the part I care about. Alright, so I'm going to hit F10. We have the state space problem, right? And we have steps, and these steps are, yeah. So this is kind of where it's already happening, right? So we're gonna stop this here. and we'll do it again. But we have to stop everything first. Alright, so everything's stopped. We're going to attach to Unity again. We're going to go here, we're going to play. Wait a second, or two, or three. Rockets, problem, facts. Okay, let's jump in instead. So yeah, that's all excellent. Collect steps, that is definitely the one I want to go to. So we're going to make a new step. Geez, I don't even know. Sure. Let's look at it. Problem, domain, operators. How many operators are there? Okay, yeah, so those are definitely the ones I'm thinking about. Collect steps for these. What is parameters? Parameters is cargo. What about the single parameter? Okay, yeah. I'm not gonna lie, I'm a little lost, but I think it's replacing cargo with cargo at this point. Alright, so what are we looking at? This is a variable, and object is cargo, so these should not be equal. Alright, so me is variable, other is cargo. Our types are the same. Cargo. Variable equals cargo. It won't, so that's a false. It's also a false. You will be alright. I really don't know what's going on. I should have stopped it way earlier, so I'm gonna stop here. Attach it to Unity again. We'll stop it here. Play it. Rocket test. Step in here. That all seems fine. Step in there. Step in there and there. and in here, and then that's as far as I think I want to step in. Alright, so here we go. Param index is what? 0. Operators dot parameters dot length. What is our parameters? Okay. So basically for every cargo, every rocket, and every location we want to get them. Alright, so we're going to get a parameter. I'm going to go ahead and close that out. Parameter is going to be cargo. Alright, and then we're going to be like, okay, object, cargo. This is our first cargo. There's a substitution set. So cargo for cargo, awesome. I'm just gonna F10 it. Maybe I shouldn't have. Alright, so what did that do? Subs. Cargo for cargo. Rocket for NOLA. Location for NOLA. Alright, so steps has 2. That's already wrong. Alright. I guess another thing I would like to know is what are our different locations? We should have NOLA in London. Okay. It's like not picking up on the London part for some reason. And I don't know why. Okay. Here we go. Problem that get objects by type. So objects, you can have an array. Yeah. Parameter is now rocket. Parameter is now, okay, location. So we definitely know in here we know that NOLA is a location. So if I hit F10 here, substitution set should definitely have NOLA as a sub. Alright, so jump in here. I don't get this part. If param index equals operator parameters dot length, oper is this, parameters is, okay, I see that, I see that. So basically now we've just added in steps, we've just added NOLA. I see that we've done that already too. Why was that? Shoot, I wasn't paying attention. Alright, so stop this, attach this. Let's try it again. Alright, rocket test, nice, nice. Back to here. F11. Here we go. Steps is 0. That's as we expected. We are gonna go in here. Then jump in here. Go in here. Jump in here. Go in here, which is location. Alright, so I'm going to jump in here. This one is going to add a step. String name, load. Variables and parameter should be cargo, rocket, NOLA. That is the string, and that's the name, the precondition, and the okay. So we made the step. Awesome. So now we're back at 2, where we're looking at location. London. Okay. Looking in here. Now we're going to look at this. Substitution. Base. Or subs. So something else happened here, I guess. So let me... Man, something else is wrong. Okay, but we're getting there. I'm starting to see where I need to go. So I'm going to uncheck this while I sort of jump in here. Yeah, I think I just want to jump in here every time we get to this function. Alright, so parameter 0, yep. That's fine. That's fine. Location, that's where we kind of need to go. Alright, so the first object is going to be NOLA, no problem. Set that substitution. So we got that substitution. So if I look at substitution, subs, that's going to go here. And if I say yep, you're done. So basically now you have a new step, which is load cargo NOLA. Perfect. Next one's gonna be London. This is where I'm concerned. Oh, I should have jumped in. Still says location NOLA. It's okay. Getting there, getting there, getting there. It's ready to go. I'm ready to go. Rocket test. View problems, view steps and facts. Let's jump in here. Alright, so here's the NOLA. Nice. London. What happens here? London term. Location is... So it does already contain London. Let's say that wasn't there. What would you have done if I do add? Oh. You're just adding it to the dictionary? Well, shoot. Can we go back to where we are? Yeah, thanks. Let's stop it here. Let's delete this line. What happens if I just leave it like this? Do I screw up everything? I'm about to check it out. Rocket test. View problem, next problem. Here we go. F10s. Let's get it until we're like at 2 and then we'll start paying attention. Alright, so this one, object is NOLA, substitution. So now if we look at the subs, subs here, got rocket NOLA. Okay, and then we'll collect steps and it'll add that step. So now we got one step. No problem. Alright, so the next one is London. We're going to do substitute NOLA. I see. So this is what we got to do. We got to somehow override it. Subs.add. I think this is just the best way to do it right there. Now, is that the right way to do it? I don't know. I didn't really pay attention to the code. Oops, oops, oops. I'm not ready. Did it? Who went? You went? Oh wait, you're okay. Rocket test. View problem. Yep. Alright, we're at 2. Nice. Alright, so first one's NOLA. Add it. No problem. Here we go. The important part. Substitutions. Subs. Ooh, now you say London. Alright. I feel good about that. I'm going to stop that here. I'm going to break this breakpoint. I'm going to... Yeah, let's just play that one more time and let's see what it says. Rocket test. Yep, view problem. View this. Okay, so now we got load cargo NOLA, load cargo London, unload cargo rocket NOLA, unload cargo rocket, fly NOLA NOLA, fly NOLA London. Okay, yeah, those are all the possible steps. Fly London London, no op, no at cargo NOLA. think that's looking pretty good, actually. Okay, okay. Since it's looking really good, show plane graph. So you can see at Rocket NOLA can go to. So if we had those two, we can load cargo at NOLA. Nice. This thing's just so huge, it's hard to see, right? But I can definitely color the lines and stuff later. I'm just comparing these to see if it maybe it just leveled off or something. I just don't know why it chose to do this again. Oh, because this grew. Ah, yeah, I see. Because this grew, it was okay. What is the goal here? The goal is to have the at Cargo London and at Rocket NOLA. Okay, so it's definitely here, so I don't know why I didn't just stop right there. And let me just check my plane graph. I'm gonna check this on the rocket domain. Alright, we're checking if these two littles exist. At cargo won't exist at 1. Won't exist. I think it should exist at 2, right? So at cargo. Sorry, right now we're testing at Cargo London, right? Okay. At Rocket NOLA. At Rocket NOLA 0. Oh, and I extend it myself, and that's why. That was my bad. Alright, cool. Alright, so that's making a lot of sense. Go rocket test. There we go. So that's when the goals exist right there. So bam. Bam, bam, thank you, ma'am. Alright, so cool. That is the playing graph. Looks good. At least it's functional. That's all I wanted to get to this point. What else am I missing, or what else should I be doing? I don't know. I said I was going to do something else, right? And I totally forgot. Maybe the README might help? The other README? I mean, maybe we just gotta start the graph plan search. So let's see if I can start doing that graph plan. Alright, so this is the graph plan I got in mind. Have to go down here. Here is the algorithm. So we did this already. Extend the plan graph until all goals are non-mutex. We didn't do the non-mutex part, but we got all goals. So let G be the current goals and initially the problem goal. So okay. I might jump out of Unity here and just go straight Visual Studio. So planning. Okay, so this loaded up. This is just my Visual Studio project, so I should be able to close the other one for now. Close this project. Alright, so we're actually out of the Unity world. And now we're here in just Visual Studio. Yeah. Okay, yeah. So, what are we going to do from here is we're going to make a graph plan. So, I might just make a whole new project. And this is how I'm going to do it. I'm going to make add a new project. It's going to be, I think this is the library. Graph plan. Let's name it graph plan prod. I can't make it online. Graph plan. But then the namespace here, we'll name graph plan project. And here we can name you graph plan. Come on. Rename my stuff, please. Graph plan, oh, okay. Graph plan project. Okay, graph plan. So graph plan, what it's gonna do is yeah, I don't know actually. Let's just make it a constructor. And all I'm gonna do is give it a plan graph. And so now we have a plan graph of all. Here we go. Let's go ahead. Private plan graph. plane graph. Plan, the other plane graph should equal this plane graph. Awesome. Anyway, at this point we should just say public void or public plan. I really don't know what to do yet, so we'll just make it void for now. Public void find plan. And so this is what will be the main focus. Let's go ahead and pass in the problem. That's what I think we're missing here. Problem. Really? Oh. Yeah, why don't you add a few references, please? Definitely the plane graph project. Let's also get the planning. Okay, that's cool. Using plane graph, awesome. And using planning. Okay, great. And then we can just say problem equals problem, and you can be a field. Great. Okay, so that's all looking pretty good. Expression, which is planning logic, and we'll say goal equals problem.goal. Let n be the current level, initially the highest level. Okay. Int n equals plane graph.get level. Is that wrong? Is it get level? What did I do wrong? Oh, yep. Let's just count levels. Okay. Something like while plane graph dot is leveled off while it's not leveled off. If n equals 0, return let's just return true. This will totally... What's going on? Oh, that's okay. If you get here, alright, so choose a set of steps S. Okay, that's a good hard one. Okay, so here we go. Choose a set of step S, which will achieve G. So basically, Um, I'm trying to say it. Choose a set of steps that will achieve G. Every pair of steps in S must be non-mutex. Add all steps in S to plan. So basically get next set of steps. And I'm just going to make them plane graph steps. I'll figure this out. Alright, I'm just going to put the code down. Plane graph set of steps. I'm not doing this yet. Add all steps to plan. Let G equal all preconditions of the step S. Goal is now gonna get new goal from steps. Excuse me, I'm gonna get an email that I sent that kinda had all this code already. Gmail.com. I hope I can find it. Ooh, it's a long old chain. Alright, I kinda have it pulled up on the other side. So this is how I'm gonna do it. This is gonna be more of a private void for now, or bool. Find plan again, but this time I'm gonna have some other stuff. Find plan. We're gonna have basically just the goal, right? Expression goal. And then if n equals, oh, I guess goal and level. If level equals 0, return true. Otherwise, I'm going to say plane graph steps equals get next set of steps. Something like this. I'll figure it out. So if I did it like this, would that be bad? I mean, and just call this set of steps. Okay. Equals get all set of steps of goal. And then of course we'll do that. And then basically we just say for each plan graph steps in set of steps we basically just have to say expression new goal equals get new goal from steps, and return find plan. No, we'll just say bool bool found plan equals find plan, and we're definitely going to do new goal and level +1 or -1, sorry. And then basically from there, if you found plan, return true. Yeah, sounds great. And then if you made it to the end here, just go ahead and give it up. Nice. So this first one, alright, so bool found plan, new goal, or actually problem goal, plane graph dot count level, or n basically. Yeah, let's just do it. N. So n's equal to that. If you found plan, return true. If you didn't, then you know what to do. Plane graph dot extend. I think that's all I had to do. Okay. Sorry, I'm just watching something right quick. Alright. Anyway. So here are the two functions I need to get. Get all set of steps, which is harder, and then get new goal. So actually let's do it this way. Get new goal first, work our way up, oops, and then get set of steps. Alright, cool. Let's do get new goal first. That one should be easier. So basically for each plane graph step in steps, step dot get child nodes. Oh, awesome. Is that what we want? Yeah, I think that's all the preconditions, right? Then we just say for each. Here we go. This is how we're gonna do this. Plane graph. List of plane graph literal. Yeah, I think that's better. This goal, let's make this a list of plane graph literals. And then instead of this, can we just say util? Is there like a util? Conversion. Shoot, I already forgot what it was called. It was in plane graph project. Conversion util. Conversion util. Dot expression to literals. Just get that to that. What do you convert it to? Okay, so you just turn u into literals. It's not bad. That's okay. I'll take that. I'll take what I can get, really. Literal. Literals equals new. List of literals. Okay. I don't mind it at all. Alright, so we got each step for each and step dot get child nodes. We're gonna do something. I'm gonna name you PG literal. If literals contains PG literal dot get literal. All you gotta do is just literals dot add PG literal. Nope. PG literal dot get literal. I like it a lot. So that's how you get the new goal. For each step, that's great. That's how that should be done. And this is how I'm going to do this part. Cool. So that's looking pretty good. Okay. Nice. Okay, let's hurry up and do this part. Goal is now a list of literals, so let's make sure we definitely get that going. So somehow we got to get the plane graph literal of this. So okay, so for each literal in goal, set of steps equals new list. Alright, cool. So for each literal, so basically we're going to grab one by one by one. So how am I going to do this? I think it's got to be recursive. I just can't put my head around it right now. Basically, we're going to have like X amount of goals, and for each goal, we're going to get all the possible steps that get that goal. So that's pretty. I think we can do that by plane graph literal PG literal equals plane graph dot get plane graph literal of literal. Or better yet, plane graph dot get. This is cool. So we have the literal. For this literal, this is how I'm going to handle it for right now. Plane graph literal, list of plane graph steps, preconditions equals new. I mean, I didn't know what else to do here. So this is how I'm going to roll it. Preconditions dot add PG literal to PG literal dot get child nodes. Yep. Gotcha. Okay. So now we basically have a dictionary of all literals and plane graph steps to do that literal. Yep, I think I'm gonna have to do level as well. Alright, this is what I'm gonna have to do for each plan graph. I'm gonna try to do plane graph step, but if not, I will I'm gonna say, hey, if plane graph dot exist at level PG literal or PG step, let's just go step at level. Alright, so we're going to say, hey, if plane graph dot no, if preconditions does contains key it should be PG literal. We will make a preconditions dot add PG literal new list of plane graph node with a plane graph node, right? I don't even know. Let's just make a new list. So list plane graph node. Well, shoot, if we already know, so we can do whatever we want now. It's not really preconditions, so I'm just gonna call it steps. Equal just this is fine. Steps dot add step. PG add steps. That's fine. Else preconditions. This is how I'm gonna roll it. Else preconditions. PG literal dot add step. Okay, that looks fine. I think I'm gonna make you a plane graph step. Yeah, that looks better. So here we got all the preconditions for, not really the preconditions, steps for steps with effect. So the effect is basically the key, and the steps are all the steps that go with that key. Alright, so now that we got all the steps with effects, we just gotta look at all the combinations. So I'm gonna do this again for each literal, and goal. So now we got every literal. We're gonna make a list of steps. So, okay, I think I'm going to be working on set of steps. So it should be basically okay, I think I know what I'm trying to do here. We're going to make this set of steps. So list plane graph step set of steps, not sets of steps, right? So this is sets of steps. Set of step equals new list. Yep. Or I could just call the steps. Sure. Okay, so we have steps. Where am I to go with this? What am I to do with this? I don't know. Oh, hey Night Guard Productions. Sorry man, didn't see you. I was too focused in the code. Uh, what am I making? I am making... Well, right now I'm trying to figure out a graph plan algorithm. So, I'm making a Sokoban game, and the graph plan algorithm is supposed to solve the problem here. So yeah. So okay, we got plane graph literal. Now we're gonna have a set of steps to achieve that literal. So how are we gonna handle it from here? So we have a goal, a literal. Um, yeah, I think just add. Why can't I think of this? We have a bunch of steps. If I want to get every combination of every list, we get the first one of the first list, and then one of the second list, one of the third list. Okay, and then with that third list, we go 1, 2, 3. So it's got to be recursive though, right? Yeah, I think so, right? It has to be. Oh my gosh, brain is blown up. So for like 10 lists, you got to get one all the way down to the last list, and then you iterate through that, and then you go up a level and iterate through that. Okay. Yeah, I'm thinking. Sorry, this is kind of hard for me. Maybe if I write it down, it might make a little more sense. So let's just put it in like Excel or something. Oops. Let's see if I have like Microsoft Office here. Yeah. Okay, so like, if I had a couple lists, like 1, 2, 3, 4, 5, A, B, C, D, X, Y, Z, I, J, K, L, and just like 100, 99, 98, 97. How would I iterate through each of these? Recursively, I guess. So I would say like for each list A, I'll just use their column header. For each list A, do something. We'll basically have a list of steps. So steps will be here. So what we'll do is add next. So next at the beginning will be 1. Then we'll say for each C, we'll add next. And so this will be A. For each E, for each E, we'll add next. So we'll get X. And then here for each G, we'll add next. So that'll be at G, I mean. And then for each I, we will add next, right? So this is me recursively going into something. And so here we go. We're going to try basically this first thing. So basically we'll have this steps array that we're passing through. Do something. Return if good. Else like return null, right? Or return bad. Okay. We'll say remove last. So at this point, we're gonna take out 100. And let's see. So we're removing last here. Make this a little bigger. Okay, so for each, remove last. Remove last and return bad. So here, return if good. Nothing really happens. Yeah, you see, I think I'm not doing the something I'm supposed to be doing. Yeah, I'm done. I don't know if what I'm doing is right or wrong. Do something, return if good. Something like that, right? But I don't know if I should be doing something at this stage. I should just be going to the next G, right? Maybe that's what this is. Do something. Alright, so return if good, return if bad. What I really want to do is just add next. Do something. But that's not the nature of recursion, right? So to create Alright. I think we need a list of lists first, right? So we're gonna have lists, and we'll have like A, B, C, or even better, we'll have C, A, C. Alright, if it wants to be that symbol, that's fine. E, G, G, I. So it has those lists, right? So, okay, for each list, you'll get for A, add next, for C, add next, for G, for I. I don't really want it to do something. I just wanted to add next. And because there is no additional list, I guess, we add next, and then you just add sequence to steps, right? And then basically you do that for each one of these eyes. And then when you're done here, you remove last eye. So you add next, add sequence, remove last eye. Okay, very cool. Okay. Yeah, I'm thinking. Jeez, this is tough. So I'm gonna try to write this in here. uh, we'll have like a list of keys and my set of steps. So list of plane graph literals. Might just be a literal. Nope, it's plane graph literals. Plane graph literals. Keys equals steps with effects dot keys. What are you? You'll return a plane graph, a list of plane graph project step. Oh yeah. Is that right? I don't think that's right. The dictionary is the key is a plane graph literal. Yeah, that's not right either. Can I implicitly convert dictionary blah? Oh, okay, well, let's just call you a key collection then, because I didn't know what to really call you. What if I just said list of plane graph literals keys equals new list of plan graph literal steps keys? Will you really take that, or you're just messing with me? Ah, alright. So we got that keys. So we have a list of keys and a set of steps, which I will put down here now. And this is how I'm going to roll it. I'm going to say set of steps equals yeah, that's kind of what we're doing, right? But this time, instead of goal and level, we're just gonna say what? Keys instead of steps. Is that all I need? Oh yeah, and we also need the very important steps with effects. Alright, so we're going to start with the first key. I have no idea. Let's just go with this and see where we can go. Okay, so we have keys, 0, set of steps, steps with effects. We're going to just say for each okay, let's see. We're going to say if keys equals null, return null. Otherwise, we'll say for each plane graph step in steps with effect keys v yeah. So we're gonna grab each step. Oh man, I can't do this right now. My brain broke. I gotta go. I'll take a little break and I'll try to come back tonight. But basically, this is the function I need to get working for getting graph plan works. And once that is working, I think we got the graph plan working, and we can just find a solution, hopefully. So we'll be back. I'm just gonna save it. I'm not even committing it or anything. So I'm just gonna stop it here. But I'll be back. Of what I was trying to do earlier, kind of just gave up in the middle of it. So we'll see if this break kind of helped me out. So what we're gonna do with each step is we are going to basically okay, we're gonna say, hey, if v is less than keys, I think I gotta do it up here. If v is less than, if it's greater than or equal to keys dot count, we do two things. We say, what is it? Step with effects. Set of steps. Set of steps. Is that something? Yeah, set of steps. Dot add new I feel like I'm missing something. So we got the dictionary, set of steps, steps with effects. Maybe I won't pass. Man, I feel like I need to pass something else too, right? Like it's not just this, which is ridiculous. Let's just set another plane graph plane graph step of steps, I guess. And then this dictionary can go down here. Something like that, right? So let's do a few things. If alright, well yeah, if keys equal, then I'll do that. If steps equals null, go ahead and say steps equal new list. Okay, and if v is greater than or equal to count, we're going to go ahead and say steps dot add. Oh, actually, set of steps. Set of steps dot add steps. Awesome. Okay, and then return set of steps. So, okay. What am I missing here? So our exit values, keys equal null, steps equals, well, really our only exit value is v is greater than the count. So for each step, we're going to jump in. So we're going to get all set of steps again. We're going to do the second one with keys v plus 1. Steps, actually we're going to make a new list of plane graph step, and we'll just pass in steps. So that's basically a clone, set of steps, and steps with effect. Hopefully that's it. And then we just return set of steps. Maybe? I'm gonna iterate through that and see how that works. Oh, looks like we still have errors, so let's figure out the errors. Oh, okay. We just gotta return the actual arrays. So we can return new plan graph step. Set of steps dot as array to array. Set of steps to array. Has the list of plane graph steps. So that is good. So we're just going to say list of plane graph. How am I going to do this? Alright. we're just gonna go for each list plane graph step. We'll call the set in set of steps for each better yet, why don't we just do this, equals new plane graph step of let's see. Cannot implicitly convert that to that. Like, I really don't think that's the way I'm supposed to be doing it. Maybe like this? No. Alright, so what did I do here? You gotta do some kind of value, so if I said 1, I don't know from here. Let's say C# array of array. Yeah, jagged array. That's what I'm trying to do. New blank blank. So jagged array is what I'm trying to do. Oh, it might help if I call it something. Yeah, that's what you want. Result. Okay, it's called the jagged array or something like that. Okay, so we got the result. The result basically for int I equals 0, I less than set of steps dot count I plus plus. For j equals 0, j less than set of steps I dot count j plus plus, and this is how we're gonna roll with it. Result I equals new. No, actually we could say equals new plane graph step array of set of steps I dot count. Yeah, that should be good. Ooh, or better yet, is just going to be set of steps I dot to array of plane graph step. Oh, that's perfect. Alright, so we don't even need all this J stuff. So, something like that. Cool. And we can just return results. I like it. I like it a lot. So what are we missing here? Better just hit F6. Here we go. Can't find that. That's okay. Oh, I can delete it. I'm not worried about it. Yeah, sure. You can be capital. You can be capital. PDDL reader now just gets problem. I think we're gonna have to say using stream reader equals new stream reader. Yeah, let's just say domain file. Domain string dot equals reader dot read to end, and then we kind of just do the same thing for problem. Problem file, problem string, read to end, and then we just pass in the domain string and the problem string. Okay. What was I just working on? I think I was on benchmark, or maybe on the test, unit test project. Now where are we? Okay. Okay, it's all built, ready to go, but I feel like something's wrong. Let's do the plane graph test. Or the benchmark, maybe. That might be better. Graph plan. Where is benchmark? Up here. Let's add a reference to it. equals new graph plan. Let's, we gotta put in the plan graph and the problem. Let's see if we can step through this code right quick. Alright, so here's the problem. We're gonna jump in. This looks fine. And that looks fine. And that's actually all. So let's do a little more. Graph plan and graph plan dot find plan. Bool found equals that. Alright. Here we go. Let's get into the meat of it. F11. Find plan. So first we get the goals, right? The goals are have cake and eat cake. Awesome. So while it's not leveled off, n is going to be 0 or 1 or 2. N is now 2. Find the plan. Okay, if level 0, it's not. Not at all. Alright, I'm just going to F10 this and see how bad it is. Yeah. I'm going to stop this here. I'm going to say, hey, if PG step equals null, let's see. I'm gonna say, I don't know. Maybe I should just leave it as is because this is the deal. Alright, I'm gonna jump in. 10 over this, F11 here. So far I'm gonna jump in here. Alright, so there we go. Alright, get all steps. Here we go. Steps with effects. So you can say level 2, but we really only have how many levels? 2 levels. Let's go ahead and on my graph plan, make sure we say level -1 here. And I think that's okay. Alright, so we're going to say find plan, count levels, find plan goes here. If levels equal to 0, great. Alright, I'm not sure if I should just do that here. I think I need to do that up here. Alright, here we go. Let's try it again. Whew, okay. I'm gonna F10 here. Got the goals. Not leveled off. I'm gonna jump in here. Level is going to be equal to 1. Yep, that makes sense. But level still not equal to 0. Jump in here. Yep, for every step. Level is good. Does not contain, so we're going to go ahead and make a new steps. I feel like I'm in an infinite loop or something. Something's happening, and it's not good.
It is like a finger pointing away to the moon. Don't concentrate on the finger or you will miss all that heavenly glory.
I broke it. Whatever's happening here, I broke it. So I'm going to try to get out of here. Yeah, I don't know what I did here. Basically, I'm just saying, hey, for each step in these child nodes, if you exist, great. If you contain key, do it there. Otherwise, just add it. Yeah, I don't know why. It did not like whatever I was putting down. Is there any way I can stop this? Maybe go to processes here. Maybe CPU. Close some of these tasks. Alright, I'll close Visual Studio. And then we'll open it back up. Hopefully that will be good. Alright, let's see. I'm gonna stop. Don't want to stop there. I do want to stop somewhere in here. Like here is good for now. Save it, and maybe even save a project. Can I do that? If I close the solution, then open project or solution, and let's just say I opened planning. There we go. Okay, so I'm gonna hit play. Hopefully we'll stop about there. Great. F10, 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 F11. Alright, so we're going to this first loop. So it's definitely not equal to 0. I don't even know why I would even return true here. So let me stop here. Um, I know I'm doing something wrong. I'm feeling it. Uh, yep, something's just fishy and wrong and all that, but I just can't put my finger on it. All right, so let's go through. Yep. Yep. So we're gonna try to find the plan. If level equals 0, return true. I gotta say, if level equals 0 and contains goals, right? I think that's definitely what's missing here. But for now, that doesn't exist. So let's jump in here. So, what I'm gonna do is make a new list called steps. We're gonna add a step there, so it should just be one step, which is eat cake. I'm gonna add that to you. Somehow I just jumped way out of there. So steps with effects. You basically have cake with one value, eat cake. Okay. Okay, so that makes sense. To have cake, you must eat cake, which is perfectly fine. So I'm going to F10 again. Alright, so to have cake, you can eat cake or no op have cake. That makes sense too. Alright, and then we gotta get the other literal. Okay, didn't like that step. Okay, so I'm gonna look at my wait, I'm not sure I like this at all. I'm gonna stop this one more time. Start this up again. Okay. Um, let's get in here. Actually, I want to stop here. Okay. Let's stop, start, and then just continue to the next one. Alright, so here we go. Got two goals. First literal is what? Have cake. Alright, so you're like, okay, first step is gonna be eat cake. Alright, so in order to have cake, right, in order to have cake, it's not child nodes. We're looking the wrong way. Dot get parent nodes. I think I'm hitting it right there. Tell me if that's right. Alright, so F10. Alright, so our literal is what? PG literals have cake. Bake cake. It doesn't exist yet, I see. But it should, right? So if I go to this, plan graph, so basically, it's only expanding it to the second level, which only has eat cake and like no step. Alright, so let's see, the other step is no op have cake. Yep, and that one does work. Okay, awesome. And then the other literal is to eat cake. And this is what we're going to find out. There's nothing that exists. So, eating cake, you have to eat cake. Okay, so it does exist. And the other step is going to be don't do anything after you've eaten cake. But that doesn't exist yet. So, okay, so if I look at my dictionary of steps with effects, to have cake, so far I could have, the possible steps I could have taken are just don't do anything. But to eaten cake, all I have to do is eat cake. Alright, good deal. Alright, so there's no more. Okay, so we got a set of steps, and we have a keys are not null, steps are null, so we're going to make a new steps. You are not there yet. So what do we have? Step is no op have cake. Jump in here. Okay, I realized something. We're not actually doing anything here. So what are we gonna do here? Step dot steps dot add step steps dot remove at the most recent index. So we'll just say steps dot count -1. I think that's the only way. Alright, so let's see. Start. Continue. Continue. Let's do it. So you're going to add a new list. Add a step to step. Pass that inwards. Second step, so we got the no op have cake and eat cake. Alright, good deal. Okay, I'm feeling better about one thing, and that is maybe my set of steps. Okay, we got a set of steps, and so the set of steps is just one set. That's no op and eat cake. Okay. I am going to just hit F10 here and maybe fail. Okay, no. New goal is now have cake, not have cake, and eaten cake. So that already doesn't make sense, but we'll see what happens. So we're going to jump in. Okay, so we're going to return true. Awesome. Found plan, return true. Okay. And if we found plan, return true. And that's it, right? Oh, nice. Okay. So you return true, but there is one fatal flaw. We have to say if level equals 0 and contains goals. Um, this is easy. Return contains goal. And then basically all I do is for each literal, and goal. For each literal and goal, if do I have a plane graph? If plane graph exists at level, let's see if we can get the PG right. Plane graph literal PG literal equals conversion util dot. No, not that. Basically plane graph dot get plane graph literal of literal. If not plane graph dot exist at level PG literal at 0, return false. Return true. Okay, and so contains goal at roots or something like that, right? Now let's kind of walk through it. Not too worried about that. But we'll walk it through from here. F10, 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 F11. So it's not quite there yet, but we got the set of steps. For each step, so you got these 3. Jump on in. Yes, let's see how we jump this in. Alright, so basically goal is going to be these 3 things. Have cake, not have cake, and eaten cake. And so first literal in here is going to be have cake. And you should totally get that. Plane graph have cake, yep. Does that exist? Should. Awesome. Literal now is not have cake. So does that exist at level 0? Return false. And then we're gonna return false. And then this next thing is gone. There's no more steps. We're gonna return false. And then since we returned false, We're going to extend the plane graph, check if it's leveled off. If it's not leveled off, we're going to go ahead and count the levels, which is now 3. Jump on in here. You are not level 0. Get all the set of steps. And hopefully set of steps is now something different. We can bake cake, then eat cake. We can just bake cake. Anyway, found planned is false, so you didn't work. You didn't work. What about this one? You didn't work, so let's try the next combination. So basically what I want to know is alright, so I'm feeling pretty good about this. Just want to see what found was here at the end. Bool was false, so it's not working. You did extend to 4. Know the answer's in there somewhere, but it didn't find it for some reason. So let's go in here. Actually, yeesh, no, not what I'm trying to do whatsoever. Alright, close all but this and get me this. Keep open. Yeah. Stop me here. Alright, so here we go. Start it up. The set of steps. I think the set of steps is working fine. Set of steps for the first one is that, and that's going to fail, so we're going to keep going. Alright, so here's the next set of steps. So I think that one should be working just fine. So 10. Once we do I don't want that as our goal, so I know that's not going to work. What's our set of steps here? To no op, eat cake, and eat cake. I won't argue with it. Alright, so this step is going to be steps which is bake cake and no op. Yeah, so that's, I definitely think that one's good. So I'm gonna kind of jump in here. So our new goals really is to that's not a really good new goal either, right? Because we're getting the wrong ones, right? Yep, that's the other problem I'm doing here. Dot get parent nodes. Alright, let's keep going. Definitely not that one. Oh snap, maybe that one? What happened? It found something, it liked something. Alright, so F10. Set of steps. So have cake and eat cake. So basically this first set of steps is going to have a new goal, which is have cake. Why? It should have more than that, right? Steps. No op have cake should have have cake, right? Oh, and eat cake is have cake, right? So eat cake. Bound plan is true. You're gonna return true, and then it's all gonna be great, which is not great at all. So our plan was basically to do two things that you can't do at the same time. So what am I supposed to do at this point? So if I went to any graph right now, maybe I still have it up here. Yeah, so this guy, right? We only got these two levels, right? And so it said, oh yeah, just use eat cake and this no op step. And if you do those two things, you should be just fine. So that is the plan graph solution to this. But that's not how it's supposed to work. So we have to use the mutexes for this graph plan search. Otherwise, yeah, I see it now. Phew. So for the non-mutex, this works. And this is probably good for fast forward and stuff. So okay, I think I got it working with no mutexes. So tomorrow or whenever I would stream next, the next thing I gotta do is to actually compute mutexes. So that's got to be the next thing if we're going to get us a real solution out of here. So, okay, good to know. Good to know. Alright, so good plan. Everything looks like it's in working order-ish. Yeah, okay. But we'll continue working on it later, next time. So what did we do so far here? If I go to my working copy. And where's my Twitch? Okay. We fixed duplication errors in rocket domain, rocket problem, and start it on graph plan. Need to get mutexes working for a legit plan. Because it's working, but since we're not competing mutexes, they're saying, hey, why don't you just eat the cake and not eat the cake at the same time, and then you'll both have cake and eat cake. And so that's logically not correct. So we have to have the mutex relations in there so that we get the right relationships. So okay, here we go. I'm going to go ahead and commit all of this. I'll just look through it right quick. View all steps, view problems, delete it fact, that's good. Hey, I did a lot of like capitalization and stuff through all of this. Alright, that looks good. Bam. Alright everybody, have a great night. I will stream again maybe tomorrow or maybe later in the week.